Okay, 6x's and, oh, thank you, x squared plus 6x's plus 8. So this is the expression. We're starting off with x squared plus 6x plus 8. Okay, and we want to figure it out, what is the factored form. So yesterday we covered GCF. Today we're going to learn how to factor into a binomial. So it's going to be x plus some number and then x plus some number. A binomial times a binomial. How do we turn it into that form? Okay, it's like undoing FOIL. Going right, FOIL, we expand it, we get the area, we have the dimensions, we have the area, now we want the dimensions. So with algebra tiles, we want to form a rectangle. We take these pieces and we need to form a rectangle. And so the only way we can form a rectangle with these pieces is if I put 2x's on one side of the x squared and 4x's on the other side. That's the only way to get our 8 ones to fit in. Because if I put in, say, 3 x's, and then this would be 3, how many ones would fill up that space? Let me show you. Okay. So if I put in instead, here's my x squared, and I have total of 6 x's, right? So what if I put 3 here and 3 here? How many ones would fit in now? 9, but how many do we have? We have 8, so we don't have a rectangle. We'd have 1 missing. Okay? If we tried x squared and we did, let's say, what else? 1 and, how many x's do we have? 6? So 5. How many ones would that make? Would we need? We need 5, but we have how many? 8, so we'd have 3 left over. Well, that's not good. So the only possible way is actually if we did 2 and 4 to put the 8 ones in. Okay? All right, so the expression for the length would be what? What's this length right here? An x? That's just the length of it is an x. And how many ones? Plus 4. What's the dimension of the width? X plus 2. So the length, x plus 4. The width is x plus 2. So the area as a product is x plus 4 times x plus 2. So and that's equivalent to x squared plus 6x plus 8. Right? This is the expanded form. The expanded form is when we get rid of the brackets. But we want to have it factored form. What are the dimensions? Length and the width. So you can write area as the length times width, or you can write it as the expanded form. Okay, let's try one together. We have how many x squareds? 1. How many x's? 5 x's and plus 4 ones. Let's try and form a rectangle. So your x's always go beside the x squared or below. Okay, we could either do 1 and 4 or 3 and 2 with our x's, splitting them up. What would we do? 1 and 4. Why is it 1 and 4? Then we can fit the 4 ones in. Well, maybe if I go like this. Bet you that'll do it. Okay, so what are the dimensions then of this rectangle? X plus how many ones? Plus 4. And x plus 1. Sorry, can't see that. All right, turn the page. Okay, can you want to try the next one on your own? Try and make a rectangle. To draw. This time you're working with an x squared, 7 negative x's, and 12. What's 12? So we have the x squared tile. That's our shaded one. We have, you could have put the 4 or the 3 on this side, doesn't matter. 1, 2, 3, 4. Now they're all negative, and that's okay. And these are all positive because two negatives multiplied together equal positive. These are shaded. Okay, so what's the dimensions? What's the dimension here? An x, and then what? Minus 3x minus 4. Yeah, so our factored form is x minus 3 times x minus 4. How could you check your work? You could actually FOIL it out or use the chart. X minus 3, x minus 4. So I have x squared minus 3x's minus 4x's and plus 12, which simplifies to what we started out with, x squared minus 7x plus 12. So you can actually FOIL or use the chart to check your work. Expand it, should be where you started. There's our answer. Good. Okay, we're going to skip that and turn to the next. Well, let's go with number 4, example 4. Okay, let's use this chart. Okay, sum and product. So, one thing you might have noticed when we did our two numbers here, -3 and -4 are the sum, right? The sum of the middle term. And then -3, -4 gave us the product of the ones. So we need to be able to find the sum and product of two numbers. So if I have, say, 12 and 20, I want two numbers that sum to 12 and product to 20. So 2 and 10, would you agree? 2 and plus 10 equal 12? Yes. Is 2 times 10 equal 20? Yeah. Okay, how about 9? Sums to 9 and product to 20. Well, what are all the ways we can multiply to 20? 1 times 20, 2 times 10, and 5 times 4. What are our two numbers? 4 and 5 add to 9 and multiply to 20. So break down your product and then figure out what the two numbers are. What two numbers multiply to 4 and add to 4? 2 and 2. 2 times 2 is 4. 2 plus 2 is 4. Okay, 18. 1 times 18, 2 times 9, 3 times 6. Anything else? Okay, which one of these would add? Am I missing something? Nope. Okay, we want a negative sum. Is that possible? -3 and -6? Okay, if they're both negative, would that multiply to positive 18? Yeah, and then add to -9. So if our sum is negative and our product is positive, they're both negative numbers, always. Let's try sum of -15, product of 4. It's much easier to break down the products than the sums because there's an infinite amount of ways to sum to -15. So, because we can use negatives and right? So there's an infinite amount. So that's why we break down the product. There's a limited amount of ways to actually multiply to 14. 1 times 14, 2 times 7. Okay, which one will add to -15? 14 and 1 if what? They're both negative. That would multiply to a positive and add to a negative. Okay, 6. 1 times 6, 2 times 3. How do I add to -1 and multiply to -6? If we want to add to a negative, let's talk about product. If a product is negative, always one number is positive, one is negative. How you figure out which one is negative is if you're adding to a negative, the larger number is negative. So which one of these has a difference of 1 between them? 2 and 3. So because we want to add to a negative, the 3 is negative and the 2 will be positive. Will that add to negative 1? Yes. Will it multiply to negative 6? Yeah. Okay, try the last two on your own. Find the two numbers. Negative 3 and positive 5. Okay, add to positive 2 and multiply to negative 15. What are your two numbers for 48? 2 and 24. Which one's negative? Both. Good job. Okay, so notice, if the product is positive, the two integers must either be both positive or both negative. And if the product is negative, one is positive, one is negative. Okay? All right, so how do we factor these trinomials? There's two methods. There's a traditional method of decomp, which I can show you today as well if you really hate the one method that I'm going to show you, and that is called Chinese method of decomp. That's the name of it. You can Google it, and it will come up. It's a specific method. The Chinese method uses reasoning and a little bit of guess and check, and it's a lot quicker than regular traditional decomposition. Okay, so there's two types, two methods. I'm going to show you both. So let me show you traditional method 1 in A. So method 1 is traditional decomp. And I'm going to show it to you. If you love it, we can do it. But most likely you're going to like the second method, and we're going to use the second method. Okay? So traditional decomp. So traditional decomposition is we're going to start off, remember we did product and sum? Well, remember the last number, the 12, is going to be where we're going to find our product. I want to find two numbers where the product is 12 and the sum is 8. Okay, product to 12, sum is 8. What are our two numbers? Think of 12. 12, 6 and 2? Agreed? Okay, so 6 and 2. So what we're going to do is we're going to uncollect like terms. This is opposite of FOIL. We're going to go, remember in FOIL, we always had 4 things and we collected the middle term, added them together. We're going to uncollect those. So what we're doing is we're going to split apart our middle term. Our middle term, instead of writing 8x, we're going to write it as a sum of 6x and 2x. Okay. Now we have those two numbers. Guess what we do when we have 4 terms? We did it yesterday. Grouping. Okay, so group the first two. What can we factor out? X. Okay, and we're left with x plus 6. Group the second two. What can you factor out? Plus 2. We're left with x plus 6. And then our final answer would be, I'm running out of room. This is why I don't like traditional decomp. We run out of room. I guess I'll go up there. Oops, that's not a pen. That's a pen. Okay, so factor out the x plus 6, and we're left with x plus 2. There's our product. X plus 6 times x plus 2. Okay, that's traditional decomposition. Okay. So the other method is a little bit of guess and check, but still kind of the same reasoning. And it's a lot quicker and not so much writing. The problem with so much writing is you're more likely to make a mistake. That's the thing with decomp, okay? So what we're going to do is it's very similar to FOIL, working backwards. The coefficient of the x squared is a 1, right? So notice how our two first terms, x times x, multiplied to x squared, right? In FOIL, the first, right? So the same way, I'm just going to use the numbers for now. We'll put in the variable. Because 1x times 1x, yeah. Do it in where? Oh, did you run out of room for B? Yeah. Okay, let's go to C. Okay, so same idea. So the only way to multiply to 1 is 1 times 1. Only one way, okay? Now, multiplying to 12, it's a little guess a check, but you can kind of use your sum and product. Because all the ways to multiply to 12 are 1 times 2. 12, thank you. What else? 2 times 6. 3 times 4. Okay? So you can still use your two numbers, but you can also guess and check. So even if you don't actually use your two numbers. So say I don't know anything and I use 2 and 6. We multiply the diagonals, which in this case is kind of boring because 1 times itself is itself. But tomorrow we're going to have questions where, like, say that's a 2. Okay, so that's going to make it a lot more interesting. Okay, 1 times 6 is 6. 1 times 2 is 2. Does that add to 13? No, those don't add to 13. Okay, let's try something else. What would it be? You're still kind of using sum and product. What would the two numbers be? 1 and 12. Okay, 1 and 12. Now, 1 and 12, 1 times 1 is 1. 1 times 12 is 12. Does that add to the negative 13? No, what do we need with our signs? Both negative. So both of them are negative. Okay, so does that make negative 13? Yes. So what's really cool about this is when you look at this here, there's this column right there, right? 1x times 1x should equal your x squared. That's the first in the FOIL, the two first being all together. Okay, this column, those two numbers should multiply to that one. That's the last in FOIL. So in FOIL, when we had x minus 12 times x minus 1, the two first together give you that x squared, x times x. The two last in FOIL, negative 12 times negative 1, gives you that positive 12. And then the inside is from the diagonals. Because remember, x times negative 1, x times negative 1, and then negative 12 times x. That gives you this one, negative 1, or 1 times 3, negative 12, 1, x times negative 1. Okay, so this is our FOIL, basically. So here, the nice thing, we can see our two factors. There's your solutions. There's one, x minus 12, times the other one is x minus 1. Now, it's weird at first. Let's try a couple and then tell me what you think, okay? Let's go back to D. So, a lot at once. I know this is a big lesson. And there's some extra videos on the website that you can go and watch if you're still struggling tonight, okay? All right, so this guy, 1a squared, only way to multiply to 1, or 1a squared is 1 and 1. We'll fill in the variables after. We'll just start with the coefficients, so just the numbers, okay? So only way to multiply to 1 is 1 and 1. 10. Okay, what are the ways we can multiply to 10? 1 times 10 and 5 times 2. Which one do you think we're going to work with if we want this sum of negative 11? 1 and 10. Now our product is a positive, our sum is a negative. So 1 and 10, we want them to be both negative. That's the only way we'll add to a negative 11. Okay, so that works. 1 times negative 1 is negative 1. 1 times 10, or negative 10 is negative 10. That adds to negative 11. You could just throw in your variables down. So what are our two factors? A minus 10 and 1a minus 1. There you go. It doesn't matter the order they're in. Nope, because it's a 3 times 4, 4 times 3, right? Yeah, so you won't be marked wrong if you switch it the other way. So let's try E. Okay? 1y squared. The only way to multiply to 1, I'm just going to, yeah, is 1 and 1. Put that down. Okay. 4. We could either do 1 times 4 or 2 times 2. Okay, so here's an interesting thing. 1 times 4. We want to sum to 3. If I use 1 and 4, we have a problem. It would have to be a -1 to add to 3, but does that multiply to +4? No, so is this one possible? No, so this one is not possible. Not factorable. Okay, let's try the next one. So 1x squared, only way to multiply to 1. 1 and 1. Okay, 50. 1 times 50, 2 times 25, 5 times 10. I think that's it, right? What would be the numbers we're going to choose? Should I zoom in? Zoom to 300. Is that better? So big. Okay, 25 and 2, logically, because we want a sum, 1 times 2 is 2, 1 times 25 is 25. Does that add to 27? Yes. Okay, so plug. So today, notice what we're doing is type 1 trinomials. They all have a 1 in front of the x squared. That's today's lesson. So in today's lesson, type 1 are beautiful. They're super easy because you can see what your two numbers are right off the bat because you're looking at the sum and product, right? Sum of 27, product of 50. They're nice and simple. So now the signs of them were both positive, and we throw in our variable, right? This has to multiply to that. At 1x times 1x has to equal x squared. It does. These two have to multiply 50. 25 and 2? Yes. And so what's our answer? X plus 25 times x plus 2. Good. Not as bad as, I hope it's not so bad. Okay, sometimes we have a common factor. All right, let's, where are we? Let's turn to the next page. I mean, it's really the same thing. Okay, factor the following expression by removing the GCF. So remember the first step, if we have a common factor, we must common factor. What can you divide all three of these by? 4. So we're going to pull out the common factor. Put it in front, and what's left over? X squared minus 8 plus 12. Okay. So we have a 1x squared. How do we multiply to 1? 1 and 1. How do we multiply to 12? We could try 3 and 4. Would those work? That would be 7, right? The diagonals would be 7, so that wouldn't work. How about what? 6 and 2? What would we have to do with our signs? Both negative. So now we have -2 and -6. Does that add to -8? Yes. Put in our variables, and there's our answer. So x minus 6, x minus 2. Now, oh, what do we have to also add? Don't forget, there's a 4. DCF was a 4. So you can use traditional method. Does anyone want me to show you the traditional method again? No? Everyone's like, no. This is so, right? Remember how much writing the traditional method is? Lots of writing. If you want me to show you ever, we can do that. It's breaking up that middle term and then grouping and blah, blah, blah. Okay, what's the GCF of this guy? 3 and x. Divide each of these by 3x. Figure out what's left over. Okay, you should have had x squared plus 7x plus 10. Okay, all right. So coefficient of x squared is at 1. Only way to multiply to 1. 1 and 1. 10. We could do 1 and 10 and 2 and 5. What are we going to do? 2 and 5, because will that add to 7? Yes. The signs, will they both be positive, both be negative? Because we're adding to a positive 7 and multiplying to a positive 5, they're both positive. So now we can throw in our variables. Okay, what would our final answer look like? 3x, good. You didn't forget the GCF. Times x plus 2. You could write 1x if you want. And x plus 5. Okay, remember you could also check your answer by storing a number on your calculator. Typing in your original, typing in your answer, they should be the same. It's cheating, I shouldn't teach you that. It's good to show you how to check your work. I'm just kidding. Yeah, I'm teaching you how to cheat. Okay, so go to the next lesson. Turn to lesson 4. It's on page 2, thank you, 343. Okay. Now, most of this is just review of this repeat of what we just talked about. Okay. So let's actually, instead of spending all our time doing this all over again, let's do a couple that are a little different. Let's look at example number 3. Before we do example number 3, what I'd like you to do is expand this. Expand x plus 2y times x plus 4y. So use good old FOIL, or you can use a chart and expand it. So get rid of the brackets, you know, all that good stuff. We went to page 344, the top of it. X times x, and then x times 4y. And then 2y times x, 2xy, we write it alphabetically, and then 2y times 4y, 8y squared. So what was your final answer after collecting like terms? X squared plus 6xy plus 8y squared. Okay? So if we're going to go backwards, we could factor, we want to go the other direction. So we could also say that x squared plus 4xy, no, sorry, 6, right? 6xy's after collecting like terms plus 8y squared can be factored to what? X plus 2y times x plus 4y, right? Because the factored form means the multiplication form. So the multiplication form of that is x plus 2y times x plus 4y. So we factor these the same way. We just have to add on an extra variable if there's an x squared and a y squared. So starting with the 1x squared, how do we multiply to 1? 1 and 1. Okay, multiplying to 30. Be careful because you really need to care. 30 is a sneaky one. The reason why it's sneaky, depending on the signs, there's 2 ways to add to 13. Okay, if the signs are opposite, then -2 plus 15, is that 13? Yeah. Or if the signs are the same, 3 plus 10, that's 13 as well. So in this case, do we want our signs to be different or the same? We're multiplying to a positive, so they have to be the same sign. So what 2 numbers should we use? 3 and 10. Because if we multiply the diagonals, we get 10 and 3. And does 10 and 3 equal 13? Yes. Okay, so now we need to put in our variables. Remember I said that these two have to multiply to x squared. So what is it going to be? I'll zoom in again. Boom. That's better. No? X and x. Remember these two have to multiply to 30y squared. What are the 2 variables? 3y and 10y. So our factored form is, remember these are positives, x plus 3y times x plus 10y. Can you try B on your own? Two and 36. 3 times 24. 4 goes in, right? 18. 6 and not 8. 12. Yes, 12, of course. And that's it? Nope. 8. 8 and 9. Okay, that's a big factor tree. You might not have needed to go that far, because our sum is 71. So the only logical answer would be what two numbers? -1 and +72. Because we want to add to a +71. So if we want to multiply to a negative but add to a positive, the larger number is positive. And that adds to 71. Okay, just throw in your variables. So this should have, the 1 and 1 should have an x and an x. And the 1 and 72 should have a y. So our answer is x minus y times x plus 72y. Okay, one more. Then we're done our lesson. Yeah. You like this lesson? Oh, nice. That's so good to hear. I thought you were all going to throw tomatoes at me. That's tomorrow. Okay. I'll write. I'm going to be really scary tomorrow. Okay, I'm serious. Bring your diapers. Okay. So, where do we start with number, or letter, I guess, letter C? You don't know. You said it. Greatest common factor. Always check, especially if your A value is not 1. Like, it's obvious that when your A value is 1, there is no GCF, unless there's a variable. Okay, so we want to pull out our greatest common factor. What can we divide all of those by? 3. A squared minus 5AB minus 84B squared. Okay. 84, that's a fun one. 1 and 84, 2 and 42. There we go. 3 goes in because 8 plus 4 is 12. So 3 times what? 3 times 28. 4. Does 4 go into 84? Yes. 21. Yeah. Ooh, 7 is going to go in because 21 is a factor, meaning 7 is a factor. 5, no. Well, 6, yes. 2 and 3 are both factors, so 6 times, well, let's see here. That would be 14. Yeah. 7 will be 7 times 12. Yeah. And I think that's it. Okay. What is the answer? Which ones do we want to use? Okay, we're multiplying to a negative, so 1 positive, 1 negative, and the larger number is negative because we want to add to a negative. So it would be positive 7, negative 12. So we have 1 and 1, a positive 7, and a minus 12 because the diagonals here. The reason why I'm getting in the habit of multiplying the diagonals and adding is because tomorrow it really will make a difference. So, yeah, we're learning. You're welcome. Okay. You guys are crazy. You're so crazy. Okay, this is a real class. We do learning here. I'm just kidding. Don't tell your English. I was just just to show you. Okay, what is it multiplied 3 times? So put your GCF in front and then a plus 7b, a minus 12b. All right, there you go. So your assignment for today is turn back to the first lesson 3. If you weren't here yesterday, you missed getting a booklet, and that's over in the side. My personal phone? Oh. Okay. Numbers 2, 3, A and C, 4, 5 to 7 eighths. So 5 ACE, 6 ACE, 7 ACE, 8, 10 AC, 12 and 13. A little bit more. Some of these will be really quick, I promise. Some of them 344, 3 to 4 AC, 5 and 8 to 11. And then your booklet, page 39. Okay. So, this stuff, the more you practice, the better you get, and the quicker you'll get. If you know your times tables, you'll also notice that you're a lot quicker than those numbers that you don't know your times tables for, right? When it's like 12, you're like, oh, I got this. Page 39. Work booklet, page 39. Remember that little booklet? Yeah? 39. At the bottom. Okay, yeah. It starts at 35.
Oh, it's like.
And then the answers are at the back. Yeah.
It goes 35.
Yeah. Yeah. It's because it's in order. So it's technically the second page of your booklet. Okay. Yeah. So we're gonna do more of. So the nice thing is especially if you practice this stuff tonight and get it down, tomorrow won't seem so difficult. Do more of the same. Okay. The whole rest of the unit is like this. Okay, I just need to push.